Welcome back to Math Concepts. What I'm going to be looking at today is how do we factor trinomials, right? How do we factor trinomials easily, right? So we want to factor trinomials when a is greater than 1, right? We want to factor trinomials when a is greater than 1. So we're looking at factoring this. All right, let's look at our first example. Example 1. So let us say I have 3p squared minus 2p minus 15 minus 5. So 3p squared minus 2p minus 5. First thing we want to do is to identify what is a, what is b, and what is c. So a is always the coefficient of the square, so it is 3. So a is 3. B is the coefficient of the p, so it is -2, and c is -5. One of the first things we want to do is to find AC. AC is to multiply the value for A times the value for C. So we're seeing where the value for A is 3, the value for C is -5. So we're going to multiply 3 times -5, and that is going to give us -15. So we want to take this into consideration, -15. Now, as soon as we have this, you want to drop your magic X. So we're going to be using the magic X, where I'm going to put AC here, which is -15. I'm going to put my B value here, which is -2. And I'm going to leave a space here that I'm going to try to put two numbers that will do this for me. So the numbers that I'm going to be looking for, they are factors of AC, which means that they could go into this number here. All right. If I should multiply these, if I should multiply them, it's going to give me back AC, which is -15. And if I should add these same numbers that I'm searching for, it's going to give me -2, which is my B value right here. So that's the context on which we're going to operate every time. The two numbers should multiply to give me back AC, and they should add to give me B. But what we need to do is just to find a list of the possible values. So let us think of 15. 15 times 1 gives 15. 5 times 3 gives 15. So these are the only possible pairs that could actually multiply to give 15. So I'll be picking from these. Which one of these I could get a 2 from? Well, definitely the 5 and the 3, right? So we could think about this now. Whenever AC is negative, and this is something that you have to pay attention to, when AC is a negative number, one of my pair will be positive and one will be negative. So one of these, so it's either I'll have -5 and a +3, or I'd have a +5 and a -3. So it's going to be one of these. I would suggest to you that let the bigger number take any sign B has. Take a look at what B is. B is a negative number. So I'm going to take the bigger one to be negative right here. So take a look. -5 times 3, -15. -5 plus 3, -2. So these numbers do work as is. So let's put them in -5 and 3. Now, when you're reaching here, we're almost at the end of the journey. What we're going to do is divide by A. Divide these special numbers that we just found by A. There they are. Let's go. So I'm going to divide it by A. A is 3. A is 3. All right. So let's take a look. Now, whenever you divide them by the A, if the A could divide into them, like if it is divisible, then you break it down, you reduce it. But if not, you leave it. So in this case, -5 over the 3 is the final stop. But 3 over 3 is not the final stop. I could say 3 into itself is 1, 3 into itself is 1. So I just divide by 3 here because it can happen. So the final stop is 1 over 1. What do we do with these? Well, this is what you do with your final stop. You open two parentheses. The denominator will actually form as the coefficient of the x, or in this case, the coefficient of the p. So you will have this coming here as 3p, and the numerator, which is -5, will come here as the second term. Then we have a 1 here at the bottom here. It's going to come here as 1p, but 1p is just p. And then the +1 at the top comes here as my second term, +1. It's done. So that is how we quickly can factorize when they using the magic X, right? But let's take a look at another problem. Let's go. First, we want to list our A, B, and C. A is 3 because it's the coefficient of the square. B is -8, and C is 4. Let us find what's the value for AC. It's going to be 3 times 4, and that is +12. Whenever my AC is a positive number, there are only 2 possibilities as it relates to the signs of the numbers that multiply. It's either I have 2 positive numbers that are multiplying or 2 negative numbers. So it's going to be one of those cases, but we'll get there soon. Now, I want us to quickly drop our magic X. AC will come here. AC is 12, and B is -8. I'm going to look for 2 numbers that will satisfy 2 conditions. I'm going to put it here. These numbers will multiply to give me back my +12, which is AC, and they will be added to give me back my -8, which is my B. Those numbers, however, are factors of 12. So let us list the factor pairs of 12. 12 times 1 gives 12. 6 times 2 gives 12. 4 times 3 gives 12. I will be picking one of these pairs. These are the only possible pairs that could work. Now, which one of these could give an 8? Well, I'm seeing 6 and 2. Let's take them out in isolation. Now, here's the deal. AC is positive, which means that I only have a few possibilities. When AC is positive, it's either I have 2 positive numbers to work with or 2 negative numbers to work with. Now, if you look at B, and B is a negative number, in this case, it's 2 negative numbers. If B were positive, it's 2 positive numbers. So B is negative. That is going to say, oh, I need to use -6 and -2. -6, -2. Let's do the math. -6 times, so I'm right here, -6 times -2, +12. -6 plus -2, -8. So -6 and -2, they do work, all right? So in this case, now we're almost there. We could open our parentheses. What we're going to do is to divide by A. A is 3. I'm dividing by 3, dividing by 3, right? So A is 3 right there. So as you could see, I could reduce this here because 3 into itself is 1. 3 into the 6 is 2. So I'm having 1 at my denominator and a -2 up there. For this one, this is where it stops because a 3 cannot go into the 2. Neither can I find a number outside of number 1 to break it down. So that's the final stop. Remember though, at this stage, what we're going to do is to take the denominator and it's going to become the coefficient of the variable, which is n. So I'm not going to say 1n, okay? Because 1n is just n. And then we put the -2 here because the 1 on top is the second term. So the first term is your denominator. It helps with the first term, the denominator helps to form that, all right? So it's the coefficient of the variable. And then the second term is your numerator. So in this case, we're talking about 3 with the n denominator, and then the -2 is on top. So it's a -2 right there. We're done. So that is how we quickly use the magic X whenever we're factorizing trinomials where A is greater than 1. So what I'm suggesting is that we just need to pay attention to the details of the problems, but we have to, at all times, come up with finding those factor pairs that they do multiply to give you back A, C, but when you add them, you'll get B. The moment you find them, then everything is good. See you next time, Dilemmas Concepts.